You are welcome for the third episode from force and pressure. Previous class we discussed about what is pressure. Pressure means force acting over a unit area. That means pressure is equal to force by area. Now, and also we discussed about how force and area are related. Here area is in the denominator. So, as the area increases, pressure decrease. Area increase, pressure decrease. That we used in some cases. And when area decrease, the pressure increase. That also we used in everyday life activities. Example in life, and also sewing needle with the sharpened, and also syringe with the sharpened. There are we used to decrease area so that increase pressure. Now we want to know liquid also can exert pressure. Can liquid also exert pressure? For that, let us do one small activity. Now, one small activity for you. See, here a balloon is fixed at the mouth of the bottle. Now, I am going to pour water in this bottle. See, now the balloon bulges. See, if I am pouring more water, its bulge becomes more, because when the height increase, that means the height of water increase, the pressure exerted by it also increase. From this activity, you come to one thing, that as the height of liquid increase or height of the liquid column increase, pressure exerted by it also increase. From this, we can conclude one point, that liquid can exert pressure, and that pressure depends on height of the liquid column. Pressure exerted by liquid depends on the height of the liquid column. Now, check another activity. Listen here. That is, here is a bottle, just like this bottle, with a side tube, and it is connected with a balloon. When water is pouring to this bottle, the balloon bulges or expand. Why? Because this liquid, here we taken water. This water can exert pressure in the sideways also. That means a liquid can exert pressure. The container on its side, the container in which we took that liquid, that water or any other liquid, that can exert pressure on its sides also. Now, to understand, one more activity we can do. See, here is a bottle. Here I made so many holes. You can do this in your home also. Here, all the holes are at the same height. Now, I am going to pour water to this bottle. Observe through which hole water is coming. See, when water is pouring to this bottle, water is coming through all the holes equally. That means this liquid, such as water, can exert pressure on its side equally. That means liquid can exert pressure that will vertically downward, not only vertically, but it also can exert pressure on its sides of the container, on its side of the container. So liquid pressure depends on two factors on, that is it depends on height of the liquid column. Liquid pressure depends on height of the liquid column. That means as the height increases, pressure exerted by the liquid also increases. That is vertically downward. Not only vertically downward, liquid can exert the pressure sides of the container also. Sides of the container also. So liquid pressure vertically downward and also it exerts on the sides of the container. Now see, if instead of water, if we choose some other liquids such as kerosene or turpentine or etc. any other liquids, that all can exert pressure, but the amount of pressure exerted by the liquid, there also depends on its height of the liquid column. This height of the liquid columns, so the pressure exerted by a liquid P is equal to HdG. Here H is the height, D is the density of the liquid, and G is the acceleration due to gravity. From this relation we can find the pressure exerted by a liquid. Pressure exerted by a liquid P is equal to what is HdG. Now we want to know gas can also exert pressure. We know air is surrounded with us. That air is called atmosphere. That means what is actually atmosphere? Earth is surrounded with a gaseous envelope. That means Earth is surrounded with air, and that air is called atmosphere. This air can also exert pressure. For example, see, this is an inflated balloon. After inflating, its mouth is tied. Otherwise, what will happen? If the balloon's mouth is not tied with the toy, if I am catch at this place, what will happen? All the air is go out. This means the air inside the balloon exerting pressure. Air inside the balloon exerting pressure. Because of that, we are tied to this mouth. Now, if suppose this balloon, if this balloon is with holes, can we inflate it? Can we inflate this balloon if its sides with a hole? No, because air can exert pressure inside of the container. Air can exert pressure inside of the container. Now, once again, what is actually atmosphere? We are surrounded with air, and that air exerts pressure. We are surrounded with air, and that is called atmosphere. or earth is surrounded with the air and that envelope is called atmosphere. Now our activity is this, to this inflated balloon, inside of this inflated balloon air is exerting pressure. If this end is open, the air is not stay inside this zone. Now you see, we know pressure is actually force acting per unit area. Force acting on a unit area. Take a very long tube of side unit area, and when this tube is very long, the air inside it, how much is the weight of the air inside it of unit area, that is equal to the pressure exerted by atmosphere. Pressure exerted by atmosphere, that is a unit area we consider, and for a very long tube, what or how much is the weight of the air inside this tube, that is the pressure at that point. That is the pressure at that point. Now we can take one example. For example, a rubber sucker. A rubber sucker. Now we are going to fix on a very polished surface. After fixing that sucker on the wall, if we try to pull it out, we find it is very difficult. Why? Because when we fix the sucker on the surface of a very polished surface, when we fix it, most of the air inside between the sucker and the surface went out. So due to this pressure difference or due to atmospheric pressure, that fix or atmospheric pressure fixed that sucker on that surface. So it is very difficult to taken out. If the air is completely taken out, then it is impossible to take that sucker from that surface. Another one more example, just you see here, suppose our head is of 15 centimeter into 15 centimeter. That is, our head is with the size of 15 centimeter into 15 centimeter area. Suppose above that, just like this figure, the air above this exerting a pressure equal to 225 kg weight. 225 kg weight is equal to 225 into 10, that is equal to 2250 Newton. This weight is very large. That is the weight of the air above our head acting just like this is very high. That is equal to how much? 225 kg. This 225 kg is equivalent to 2250 Newton. Because of this very high pressure, our body will be crushed. But actually, is it happening? If our body is crushing due to the air above our head? No. Why? Because whatever is the pressure exerting on our head, the same pressure is within our body, so the pressure is balancing. So the force acting on unit area, pressure is balancing. Why? Because whatever is the pressure above our head, that is 225 kilogram weight, that much pressure is inside our body also. Both that forces balance, because of that our body is not damaging or crushing. But when we go up some hill or mountain, there gradually the pressure decreases, but our body pressure there is high. Because of that, mountaineers sometimes sometimes face nasal bleeding. While suppose here one question is asking why mountaineers face nasal bleeding sometimes, because here we know both the pressure, above pressure, our body pressure will be the same. But as we go up, height increase, pressure gradually decrease due to the difference in pressure difference. Some blood veins in our nose can break, because of that nasal bleeding happen. Now, see one more activity to find out. One more activity to find out. For example, to find out how much is the atmospheric pressure. Is a person, Otto von Guericke did an experiment. Because of that, just like this, you see, this is two hemisphere attached or fixed. And see, by using devices inside a pressure, that means air completely removed. Because of that, the air inside is nothing. That means air pressure inside is zero. That means very small. But due to the atmospheric pressure, these two hemisphere attached off. Now see, both sides there are 8 forces pulling each other to separate that hemisphere. That means it is that much difficult to separate them, because due to the atmospheric pressure. So you got idea about how much is the atmospheric pressure, how much that is equivalent to the pulling of 8 force from both sides of the hemisphere. That much pressure is acting. Okay, the unit we used to measure this atmospheric pressure is bar, is the atmospheric pressure we used to measure this one. Okay, now see, from this unit, the things we want to remember. 1. Force. What is actually a force? It is a push or pull. What can it do? It can change the speed, direction, shape, etc. What is actually force? It is an interaction between two bodies. Force is an interaction between two bodies. Now, force has both magnitude and direction. Force is a quantity with magnitude and direction. What can do force? Force can change state of motion. Force can change state of motion. What are the things you have to remember about force? Force is a push or pull. It is an interaction between two bodies. It has both magnitude and direction. It can change the state of motion. Now, next term, pressure. What are the things you want to remember about pressure? Force per unit area is pressure. Force acting over a unit area is pressure. So, pressure is equal to force by area. Liquid, gas, liquid and gas also can exert pressure. Liquid and gases can also exert pressure. These liquids and gas exert pressure on the walls of the container. That means in which the liquid or gas is present, on its walls it can exert pressure. Now, what is actually atmospheric pressure? What is actually atmospheric pressure? Air around us is called atmosphere, and the pressure exerted by it is called atmospheric pressure. Air around us is called atmosphere, and the pressure exerted by it is called atmospheric pressure. Now, we are going to answer some textual questions. See, first one. Give 2 examples each of situations in which you push or pull change the state of motion of an object. That means a push or pull change the state of motion. Example, a table is pulling. It it will move to one side. So its state of motion changing. Suppose a ball moving, again we kick, then its speed increase. Then also its state of motion changes. Second question, give 2 examples of situation in which applied forces cause a change in the shape of an object. You want to find out and give 2 examples of a situation in which applied force causes a change in the shape of an object. That means when you apply a force on a body, that it changes the shape of an object. Example, a sponge we press it, then its shape will change. Pulling a spring or rubber band, then its shape will change. Now the third question, fill in the blanks in the following statements. To draw water from a well, we have to dash at the rock. Suppose we want to take water from a well by using rock. We want to pull. Answer is we want to pull the rock. And it should be a charged body dash an uncharged body towards it. A charged body can attract an uncharged body. A charged body can attract an uncharged body. And that force is called what? Electrostatic force. What is called electrostatic force? Here answer is attracts. And third question, C. To move a loaded trolley, we have to push it. We have to push it. A loaded trolley, suppose we want to move. We want to push it and that force we exerting is called what is muscular force. Because force is exerted by our muscles. And question B, the north pole of a magnet dash the north pole of another magnet. When 2 north pole comes, we know they attract each other. North pole, repel each other. Unlike poles attract, like poles repel. To south or to north repel each other. A north and south attract each other. Now, question number 4th one. An archer stretches her bow while taking aim at the target. She then releases the arrow, which begins to move towards the target. Based on this information, fill up the gaps in the following statements using the following terms. An archer stretches her bow while taking aim at the target. She releases the arrow, which begins to move towards the target. Based on this information, fill up the gaps in the following statement using the following terms. You can use muscular force, contact, non-contact, gravity, friction, shape, attraction. Among these questions, first one, to stretch the bow, the archer applies a force that causes a change in its shape. Answer is shape, the force which changes the shape of the bow. Next, the force applied by the archer to stretch the bow is an example of muscular force. Is an example of muscular force because muscles do the work for exerting the force. The type of force responsible for change in the state of motion of an arrow is an example of it is a contact force. Which force is contact force is an example for that. While the arrow moves towards the target, the force acting on it are due to which are the force acting when the arrow is moving towards the target. On gravity, it is attracting downward, and another one is the frictional force which opposing its motion. Then the answer is on gravity, and another one is friction. Now, 5th question. In the following situations, identify the agent exerting the force and the object on which it acts. You are to identify at first who is the agent applying force, who is applying force, and the object on which it acts, in which object that is acting. Then state the effect of the force on each case. You want to state the effect of force in each case. First is squeezing a piece of lemon between the fingers to extract its juice. Suppose you want to extract juice from a lemon, then what is the effect? Because its effect is changing its shape. Because by squeezing the lemon, its shape is changing. Taking out the paste from a toothpaste tube. Suppose you want to take a paste from a toothpaste tube, when you press it, its shape changes. Its shape changes. Which force they are using is muscular. But what is actually the action of force is the shape changing. And third one, a load suspended from a spring, while its other end is on a hook fixed to a wall. When we suspend a load on a spring, then it stretches. That means changing the shape. Changing the shape. Then an athlete making a high jump to clear the ball at a certain height. Suppose an athlete jumps for a high jump, then what is actually happening? He jumping upward and his shape will change because he is not jumping as the straight body with a straight body, but he is bending his body to jump more. That is the answer for 5th question. Now 6th question. A blacksmith hammers a hot piece of iron while making a tool. How does the force due to hammering affect the piece of iron? That force of hammering change the shape of the iron. Change the shape. And the 7th question. An inflated balloon was pressed against the wall after it has been rubbed with a piece of synthetic cloth. It was found the balloon sticks to the wall. The force might be responsible for the attraction between the balloon and the wall is electrostatic force. Which force is the attraction of balloon there happening? It is the electrostatic force. And 8th question. Name the force acting a plastic bucket containing water held above the ground level in your hand. Discuss why the force acting on the bucket do not bring a change in its state of motion. When we hold a bucket containing water like this way, what is the force acting on its weight is acting vertically downward. And another one is what is a normal reaction acting upward. Which are the two forces there? On weight of the bucket, that means water downward, and normal reaction acting in the upward direction. And the 9th question. A rocket has been fired upwards to launch a satellite. A rocket has been fired upwards to launch a satellite in its orbit. Name the two forces acting on the rocket immediately after leaving the launching pad. When a rocket is going upward, we know it exerts burned gases downward. That force is the action. And then the atmosphere exerts a force in the upward direction, that is the reaction. So the two forces acting on it are the action and reaction. And the 10th question. When we press the bulb of a dropper with a nozzle kept in water, air in the dropper is seen to escape in the form of bubbles. Once we release the pressure on the bulb, water gets filled in the dropper. The rise of water in the dropper is due to atmospheric pressure. Suppose when we fill or when we take a medicine in the injection syringe, what is actually we pressing air inside it out, then the pressure inside will decrease, hence the atmosphere pressure push the medicine into the syringe. Okay, now these are the things we want to remember from this unit. Okay, now you want to remember the things which we discussed today. Which are they? What is force? What force can do? What is pressure? What pressure can do? When does pressure increase? Has the area increase or decrease? To increase pressure, area must decrease for a given force. To decrease pressure, area want to increase for a given force. Then atmospheric pressure exerted by liquid. How the pressure exerted by liquid depends on, that means pressure exerted by the liquid depends on its height of the liquid column. Then pressure exerted by the gases. Pressure exerted by the gases, it is too enormous force, but we are not feeling it because whatever is the pressure outside, that much pressure is within our body, so we are not feeling it. With this, we can wind up this class.